Hey, what's going on, guys? KIM-1 here. In this video I'd like to demonstrate how to load a paper tape into my Arduino based KIM-1 emulator and how to dump the paper tape back from, like, literally to make sort of a memory dump, but to store it in a paper tape specific format. So that's the text format, storing the binary footprint using the ASCII characters and also using some rudimentary checksums. And well, that's just the paper tape format. Okay, and also I wanted to, as a bit of a bonus, I want to demonstrate a fantastic assembler I found. So there is a very nice assembler by Aart Bik. Well, I know him for creating a fantastic chess apps on Google Play Market, but it turned out that he's a fan of retro computing as well, and he's created a full-blown 6502 assembler, which we're going to be making use of as well. That's just a single file. It's available for both for Linux and for Windows. Oh, thanks, man. And well, without further ado, let's actually start. So I've already uploaded the latest update of the code to my Arduino, and yeah, before I forgot, I just forgot to give a credit to Oscar Vermeulen, the author of KIM-1 in the previous video, because I've reused this 3 intercepts for RAM calls for outputting the character, getting the character from the serial port. Well, I've changed the code. It's a bit different, but the idea behind this program counter jumps to skip the subroutine and returning the no operation opcode to fake return from the subroutine is really helpful. And when this was done for, like, displaying the LEDs and things like that, that was resulting in, let's say, inaccurate behavior of the outputs. But for serial communication, this is fairly enough, so I decided just to reuse this sort of a thing as well. So outputting character, getting character, and intercepting the setup of the random bits per second delay for the TTY. Okay, now we're ready to go. So I'm gonna be using Putty here. So let me just start a new connection. Okay, wrong password. Okay, so I want to run this one and just make the terminal a bit like well, this should be just fine. Okay, so here is the terminal. And yeah, so the problem within the previous video was it wasn't capable of uploading the data from the paper tape, and the reason for that, which is important, the reason for that was when I've been reading this get character, I was reading from like using this Arduino serial.read standard function. But the problem is that when there is nothing there, no character is pressed, Arduino returns the value of FF, while the KIM-ROM is expecting for the value 00. So in this tiny little line, I managed to fix that, and now it seems to works like a charm. So here we're gonna be loading the paper tape, but before that, let's actually create the paper tape. And here is the time for this fantastic 6502 assembler by Aart Bik. So here I've drafted a very simple hello world program. So all it does is just prints hello world to the serial port. Nothing special, nothing special really. So it uses the output character KIM-1 RAM call. So it's the address for that. It starts, the origin is 200 hexadecimal, so the program would be loaded at 200 hexadecimal. And we have this string with some new line characters followed by the carriage with the carriage returns followed by the new line characters, and now the new line here. So we're using X as the counter to walk through the bytes. And in the case if the 0 flag is set to 1, which means that we've loaded this byte, we just go into the exit label and break from the program, and we're done. We're back to the KIM-ROM after. Otherwise, we're printing the character, whatever character we have in the A register. So here I'm using the Well, I'm not sure how exactly it assembles. Whether no, it's probably not. It's probably not the 0-page as far as it's here. It's probably using the absolute address. So yeah, absolute addressing with an X offset, with an plus the whatever value in the X register is an offset to be loaded into the A register. All right. So now let's try to compile this. Nope, not here. So I want to not the terminal, just the directory. So view folder. So here is oh, shouldn't be doing that, sorry. Okay, it's probably I'm extremely sorry for this. It's probably running there in the background. Nope. Okay, great. So opening a terminal, or I probably already have one. Yeah, probably already have one. Yeah, so that's just clear. So we are at the software. All right, and here hello.asm. So far so good. So if I say lean to C64, so by default it just by default it just starts this sort of interactive assembler, but we don't need that. Instead, we just have a look at the help. So it's a fantastic help, very tight and to the point. So we need this -p parameter to use with the paper tape, and don't even need to specify the target file, only the source file. So lean to 64 -p or -p, and then hello and hello.asm, this file. So literally trying to assemble this file, and here we go. So it just creates the 35 bytes. Okay, so output paper text format. So far so good. So now if we have a look, well actually here in software it just created this. Okay, man, it just created this paper text paper tape text file. And here we have the number of bytes following in hexadecimal up to here, then from here to here. Then this is the origin of where this byte is about to be loaded. So this is the first byte, second byte, third byte, and so on. And this 4 digits at the end is the checksum, just to make sure that we didn't lose anything during the sending these bytes. Next line, and then the like whatever bytes we want, and finally we have like the final checksum for all we've sent. Now this file, this is the text file, and we're about to be sending this to our Arduino via the serial port. So the KIM-ROM is about to accept this. So here I press Shift L, and nothing happens for now. But if we now drop back to, where do we drop back? To here. And here, if I say sudo python 3, so I have another file called send.py, which literally opens the dev TTY USB on my machine. So if you're in Windows, then most likely you can use something like real-term to just decrease the number of bps to make sure it's not too fast, and you can just fit the file in using the nice GUI. But on Linux I don't have that, so I've created this custom Python script just to write to the dev TTY USB where my Arduino is connected to. Note that I'm not writing the bytes but writing the characters, so not WB but just W here. So I'm going to be writing the characters to this device, or like to the serial port literally. And yeah, just making sure to add the carriage return if we're having a new line fit, because on Linux we don't use the carriage returns. And also this is the minimal delay, that is it's kind of the fastest way of uploading the file, but if we make it faster it just starts skipping the bytes. If we make it slower it just would be slow as hell. So this trivial code actually allows us to write this bytes to via the serial port to my Arduino-based KIM-1 emulator. So that's what I'm supposed to be running now at the moment. So so sudo just to be able to write to USB, Python 3 send.py, and the file is called ax.pdf. That's the file that we've just, this one. And here we go. The password again. And now it starts sending the data, so send the first line, the second line, and it's done. And now we go back here, and you see like it says KIM, which means it did reset, enter the ROM again. Otherwise, there would be error KIM if something goes wrong, if the checksum is not matched or things like that. And if we now go to 0200, and we have this bytes, exactly the bytes. So you see like A200BD0F. So these are the bytes. A200BD0F. So these are the bytes of our program that we've just put into the memory. So I'm going back to 0200 and Shift G to run, and here we go. We got hello world. Fantastic, right? So assembling assembling the file using the 658 assembler by Aart Bik, then transferring this to the serial port to the Arduino based KIM-1 emulator and running, and we have this hello world. But now what do we want to do on the contrary? So let's say we've developed the program in machine codes, which I really love to do, and now we have these bytes in the memory, but let's consider we've done this here within the emulator. We want to store our work. So how one can do that? And now here I'm sort of just doing my notes. So here is how we go. So I need to go to address 17F7 and specify the least significant bit of the end address where we should stop. And let's just pick up the entire page from 200 hexadecimal to 02FF. So I say FF here and dot to store, and then 02 and store. And just to check this, 17F7 FF 02. Okay, now I need to go to 0200 where the program starts, so the very first byte, and by pressing Shift Q, I've just invoked this paper tape loading. So let me just maximize. Yeah, probably. Let me just. Well, I could have. Wonder if I just say. Yeah, now it's much better. Okay. No, and it's already. Okay, I'm sorry. All right. 17F7. Go there. 17F7. Okay. Okay. 0200. Okay, and Shift Q. All right. Here is the paper tape. So I grab it, and it's already, once it's been highlighted, it's already in the buffer. That's how the PuTTY works. And now, if I just press the mouse wheel, it just pastes in. I'm not sure how it works internally, but anyway. And you might be wondering that it's not exactly the same, but if you have a look at the first line, you'll notice that it is actually exactly the same, and it's easy to see the checksum here. And here, since it's using kind of just this empty zeros for the rest of things, just the format of paper tape a little bit different. So if I specify, well, the KIM-1 ROMs works the way that it only can handle the entire line, so it can generate the paper tape to drop somewhere in between, like this, for instance. If I'm not mistaken, but that should be the case. So anyway, if the address was not 02FF but 02 and then the length of this guys, so let's say 02, like I don't know, 02A0 for instance, then it would be shorter, like this, for instance. But anyway, the idea that it just generates the paper tape that we can store, and then we can upload this paper tape back and be happy with continuing developing the program that we've made. So this is pretty much it from my side, guys. So I hope you've enjoyed. Hope you've enjoyed this video, and I will now upload the latest update to GitHub, so you are free to play around with this as well. This is it from my side. Thanks for watching. Until next time, and take care.